Good afternoon. Thanks for joining us. This is Sean here at Zyxel, and today we are going to be talking about our wireless products. As we go through today, feel free to send in questions. To do that, use the question and answer interface because I can see those as we go through. And if it's an easy question, I'll answer it as we go through. If it's a little bit harder, I may save it for the end, or if it's something that maybe gets covered in an upcoming slide. But feel free to send in as many questions as you have. As we get started today, I'm going to first start by talking about some of the technologies and features that you find in our wireless access points. I'll then go through a sort of a brief overview of the different APs we have, some of the differences between them, how to tell by looking at the model number, sort of what features may be in that device. And then at the end, we'll talk about Wi-Fi 6E because we still get a lot of questions on what Wi-Fi 6E is. So I've chosen to save those towards the end and then specifically talk about our 6E access points as its own thing, separate from the general overview. So to start off with technology-wise, when you're looking at our access points, we've got three different types of antennas, which is about two more than most of our competition has. So depending on the model of AP you're looking at, it may have one of these three types of antennas. The first one here is a static antenna. This is what you traditionally find in an access point. This is what you'll find in, Meraki APs, Aruba APs, et cetera, et cetera. So it's a fixed antenna that covers the area directly below where the access point is intended to be mounted. Then we've also got dual optimized antennas and smart antennas. So we'll start by talking about our dual optimized antennas. So this is what you're seeing on the screen right now. This is kind of showing you how the traditional access point is designed. The assumption is that you're going to place the AP centrally located over the area that needs coverage. The signal radiates out roughly in an umbrella shape, covering the areas underneath that access point. The problem you run into, though, is out in the real world, oftentimes you don't always get to mount your access points on the ceiling above where you want to cover the area. It's very common to have to mount the access points on a wall instead, either because the ceiling lacks mounting points, or there may be a code issue with mounting something in the plenum space, or it may just be your customer doesn't want you poking holes in their drop ceiling, etc. So when you mount a ceiling mount antenna on your wall, the problem you run into is this signal is not optimized for that positioning. Everything's rotated 90 degrees, so a lot of your signal goes up into the ceiling or down into the floor rather than covering those users that are on that same floor. So our solution to this was the dual optimized antenna. And basically what we've done is on these APs that have a dual optimized antenna is we have two sets of antennas in there. One that's your traditional ceiling mount antenna and a separate one that's been optimized for wall mount. So that way you can choose on a per AP basis to use that ceiling antenna pattern or the wall antenna pattern based on where you've mounted that access point. So when you're looking at our access points, in general, if the end in the letter D, that is telling you that that access point has dual optimized antennas. The other technology we have here is smart antenna. For those of you that are familiar with Ruckus's BeamFlex and BeamFlex Plus, our smart antenna is a similar technology to that. So basically the idea behind smart antenna is to basically create the best performing wireless antenna solution that you can possibly have. It's designed to help increase capacity, both the number of AP or of client devices that can connect to the AP before you start having complaints, as well as the number of APs that can fit into a small area, increase coverage, and with our algorithm that we use, the ability to reduce interference. So again, this is just showing here's your traditional access point, your circular antenna pattern. And when you introduce noise, you run into situations where the signal degrades and you can have issues. Now, this noise can be like in this example here, a microwave or some other piece of industrial equipment in the office. It can also just be other access points operating on the same channel or other wireless devices operating on that same channel. So with smart antenna, the way our smart antenna system works is instead of having one antenna pattern like your traditional access point or tool like our dual optimized access points, we have the ability to go through hundreds of different antenna patterns. So our algorithm takes a look at where that client device is in relationship to the access point, and it takes a look at sources of interference. Again, could be industrial equipment, could be other access points, and tailors the antenna pattern to focus the signal at the client device, but also to try to avoid hearing and picking up those interfering signals. So you're able to get less interference, better performance. So we've just got a quick slide here. This is just showing us comparing our WAX 650S versus Aruba's 515. Both access points are Wi-Fi 6. Both of them are 4x4. We have a little bit more output power than they do, but you can see here the big difference between smart antenna and non-smart antenna on both transmit and receive. So a while back, the University of Brescia in Italy, their networking and computer science group got together and decided to test claims made by us and Ruckus about smart antenna technology. So they went through, they bought one of our APs, a Ruckus AP, a Cisco AP, and a HP AP, and tested them. So if you want to find the entire white paper, all the tests they did, all of the results, I believe this link here still works. You can go there. You can simply just Google Zyxel smart antenna white paper, and we have a white paper that we've put together that highlights the key takeaways. Some of those takeaways, just really quick, in co-channel interference prone environments, which is basically everywhere these days, up to 70% improvement with smart antenna versus non-smart antenna access points. Compared specifically against Cisco, 56% better performance. And then also when looking at other smart antenna vendors, in this case Ruckus, up to 45% better performance depending on the test. So now I want to talk a little bit here about some of the technologies that we have in our access points, in particular when paired with a local controller or our Nebula cloud. So we have simple, single-click, easy to use wireless mesh. This is our smart mesh technology. So you can simply go in and enable smart mesh, and access points that do not have a hardwired connection back to the network will automatically find access points that do and create a mesh network with them. The way this works is, in fact, even if you don't have it set to use smart mesh, at some point, if for some reason one of your access points gets disconnected or loses wired connection, it will automatically go into mesh mode and be able to backhaul from there. We offer dynamic pre-shared key, DPPSK. So, traditionally the way, you've always been told if you're deploying a business network is that you want to use WPA Enterprise Security, which uses 8021X to do authentication of each individual user. You don't want to use a single pre-shared key that all of the employees share, because when somebody leaves the company, now everybody either has to change their password, or alternately, you just hope that that employee doesn't come back at night and reconnect to the network because they know what the password is. But using 802.1x requires extra configuration on the client devices. Sometimes there's handshaking issues or issues with poor performance, unable to doing the authentication. So a solution to that, to provide that sort of enterprise level security with the simplicity and easiness of pre-shared key, is this dynamic pre-shared key functionality. Basically, you just provide your users their own unique password, and they connect to the SSID just like they would as if it was a standard non-enterprise WPA network, just like you do at your home with the password. But the difference is each user gets their own password. So when they connect to the SSID and authenticate using their password, on the back end, we're able to figure out who the user is that's connecting, and then we can apply dynamic VLAN rules based on who that user is. So you can make sure your sales guys have access to the sales system, but maybe are excluded from the operation sides of things or from accounting. So you can have and deploy specific VLANs for individual users without having to worry about configuring and maintaining 8021X. And then if you're using Nebula here, our Nebula Pro solution, we offer the ability to use basically artificial intelligence or machine learning to automatically optimize your network based on what we see from the access point side of things. Now, all of our business class access points, so this is basically every access point with 3 digits or more in the model name, uses this design that we have here. And this is why all of our access points, even some of our sub $100 access points, come with lifetime warranties, where most of our competitors in this space are offering only 1 or 2 year warranties. So we've got two things going on here: optimizations for the life of the product and optimizations for the wireless performance. So one of the things you will notice if you handle one of our access points after handling one of our competitors is our access points weigh a lot more. And there's a reason for that. And that's having to do with prolonging the life of the components here. So we're talking about a solid state component. So what causes failure? Number one cause of failure over time is heat fatigue. The little switches in the chips can actually get stuck, or you come into issues with the solder joints failing due to heat fatigue and flex. So what we've done on all of our access points is we've got a large metal heat sink that goes behind the main board that's designed to draw heat off of the board. And then we've got lots and lots of vent holes. You'll notice some of our competitors that don't have a lifetime warranty often have no vent holes at all. And that's part of the reason why they fail early and why they can't offer the lifetime warranty, is because due to heat issues, they will eventually fail. The other thing we do to prolong the life of our access points is we do not use any electrolytic capacitors. All of our capacitors are solid state. The next thing we do here has to do with RF performance. So you'll notice here we've got a lot more shielding on our main board than you would normally see on our competitors' access points. And the reason for that is, in addition to the normal EMI and Wi-Fi shielding that you need on your board, um, we also provide additional filtering to block out 4G and 5G signals. So 4G and 5G can cooperate on channels that are right next to 2.4 or 5 and can bleed over. Now, generally in a typical environment, it's not a problem, but if you're in a newer building or a larger building where they're using what's called a DOS system to bring 4G or 5G inside the building to help solve connection issues, because people inside the building signal can't reach the exterior, nearby cell tower, you can run into interference issues because you've got what are essentially 4G, 5G broadcasts inside the building, oftentimes very close to your access point. So this additional shielding helps protect from that. The other thing we do differently here is on most of our access points, we do not put the antennas directly onto the PCBA. We have a separate board that's isolated here with a separate little shield to help isolate it from any EMI issues from the main board. So these are separate, and it just provides that much better signal to noise ratio out in the real world. Another feature we have here is we have the ability, when pairing our access point with our gateways, to turn an access point into a remotely managed VPN appliance, right? So it's one of the challenges we have now is a lot of people are working remote, hybrid work schedules, et cetera. So they need to access their office resources when they're out working from home. So this is an easy way to do that avoids having to, configure their home computer, configure their laptop, and maintain all those, sort of complicated settings that go into VPN. Instead, what you do is you simply give them one of our access points. They take it home, they plug it into their existing router, and it works as an access point with an SSID that, when you connect to it, basically functions as a VPN back into the office. So the nice thing about this being an access point is you don't end up in a double NAT situation like you would with dedicated VPN hardware when they take that home and plug it in behind their existing router that was provided to them by, Comcast or whoever. So it solves that issue, and it gives you cloud management and automatic configuration. Now, in order to connect to that SSID and get onto the corporate network, obviously you don't want just, anybody connecting to the home Wi-Fi. So you, as an administrator, you control the security there. It does require that the people authenticate with a unique username and password onto the wireless network. And we pair that with two-factor authentication before allowing them to traverse that VPN connection. We do have a number of different outdoor solutions that are currently available for you. On the low end side of things here, we have the NWA 55AXE. So that's a IP55 rated lightweight outdoor access point. It's Wi-Fi 6 AX 1600 with 2 external antennas. We also have our little outdoor enclosure housing. So you can take an indoor access point, mount it in our enclosure, and then mount that outside. So that's IPX5 rated, so it'll help keep water off of it. It'll help expand a bit the temperature range that it can operate in. But for most areas, unless you're someplace really cold, that may be enough to easily provide outdoor access to your users and gives you the bonus that you can standardize and use the same access points both indoors and outdoors for you. And then for those of you looking for a more heavy duty solution, we have our WAC 6553D-E and the WAX 655E. So both of these are heavy duty IP66 rated enclosures. Both of them can handle temperatures down to -40 Fahrenheit in operating. Both have standard N-type connectors for external antenna connections. We sell omnidirectional antennas, or you can source your own directional antennas depending on what you need to do with it. Supports smart mesh, etc. So moving on from there, let's talk a little bit about Wi-Fi 6, what it is, some of the benefits here for you. And the shorter sort of version of this is basically Wi-Fi 6 was designed to solve a lot of the issues that have plagued Wi-Fi ever since it got ratified in the late 1990s. As I'm sure you know, if you've deployed wireless, you've used wireless at your home, there are lots of issues when it comes to deploying and troubleshooting issues, particularly when you start getting environments with lots of users or lots of access points. So Wi-Fi 6 is the first real change to the standard that was specifically designed to sort of tackle these niggling problems that continue to plague Wi-Fi up until this point. So it's faster, up to 40% faster speeds on the wireless side of things, up to 4 times the capacity, both looking at this from how many users you can fit on an access point to also dealing with, having lots of access points in the same area. It's dual band. So Wi-Fi 6 works on both the 2.4 and the 5 gigahertz radio, and also the 6 gigahertz, and we'll get to that later. But this is a big step up because 11AC only improved performance on the 5 gigahertz radio. That 2.4 radio was still using 11N technology. So with Wi-Fi 6 APs, you can now get these improvements on both of your radios. So just showing you here just how it improves the performance. So this orange line, or the lower line here, that's showing you what sort of aggregated throughput we expect to see as we add more and more users to the access point. As you see with 11AC, as you add more users, the aggregated throughput actually drops. Where with Wi-Fi 6, aggregated throughput remains almost perfectly flat no matter how many users you add on there, assuming they all support Wi-Fi 6. That just has to do with better use of airtime, better use of being able to distribute the connections amongst multiple users, the ability to help schedule when users broadcast instead of it being a free-for-all. So a lot of improvements there on these dense deployments. So now we'll move on to talking about our hardware. To try to keep things simple, we've sort of split up our access points into 3 different categories. Simplicity, these would be what I would call our SOHO targeted access points. Flexibility, these are our lower end business class APs, and then ultimate, which would be our higher class business APs. The main difference between flexible and ultimate is going to usually be bundled with 1 year of Nebula Pro Pack. Also, the ultimate will usually come with a dual optimized antenna or a smart antenna, whereas the simplicity and flexibility segments here are going to usually be just your standard fixed antenna pattern antenna. So we'll start by talking about the lower end of things here for us. So at the very low end here, we have our NWA 50AX. So that's going to be our entry level access point. This is currently an exclusive access point. For Amazon, it's what we would call Wi-Fi 6 Lite. It doesn't have the full Wi-Fi 6 feature set support. It's also missing features like WPA Enterprise, Captive Portal, stuff like that. So it's not really designed to handle business type deployments. We have our NWA55AXE, which is sort of like an outdoor version of the 50, with the added benefit that this can create bridges. So if you need to bridge two buildings together, you can do that here with the 55AXE. This would be the cheapest way to do that. And then jumping up from there to the NWA90 and NWA90AX Pro. Very similar to the NWA50AX, these are Wi-Fi 6 Lite access points, but they do add back in some of those business class features. So if you're looking, you need to go cheap and you need to use this for a business type deployment, the NWA90 series is probably about as low as you would want to go. And I will have a little comparison matrix here coming up in just a second. Going up from there, this is our flexible series here. These are what I would call our entry-level true business class access points. These are all going to be Wi-Fi 6, full Wi-Fi 6, the full Wi-Fi 6 feature set, and also access to the full feature set that's available in Nebula. These also come with lifetime warranty. So the entry-level AX1800 product is the NWA 110AX. The NWA 210AX gives you faster 5 gigahertz radio performance and gives you a multi-gig 2.5 gig uplink port. And then our 220AX-6E is our entry-level access point that supports Wi-Fi 6E or 6 gigahertz operation. And again, I will come back around and talk more in depth here on Wi-Fi 6E in just a little bit. So here's that comparison slide to sort of try to make this easier to understand what the differences are here on our different AX1800 access points. So as you can see here, the 50 and 55 AX are missing MAC authentication, radius authentication, captive portal, layer 2 isolation. Those features then get added in on the 90. And then jumping up to the NWA 110AX and higher, you also get things like load balancing, dynamic pre-shared key, the ability to perform NAT on a per SSID basis hosted there on the access point, SNMP management, auto optimization, the ability to use our Connect and Protect Plus, etc., and then the lifetime warranties. So moving on from there, we'll jump up here into the Ultimate series. So again, these guys here are all pretty much all going to have dual optimized antenna or smart antenna for us, and they all come bundled with our Nebula Flex Pro, so you get a 1-year license of that. These are also the models that can be managed with the wireless LAN controller that's built into our USG Flex and ATP series. So if you want to do a larger network, you don't want to use cloud, you can still do local controller management by using one of our gateways as a controller. So here, the entry level model here is the WAX510D, dual optimized antennas. The 610D is a step up from that. So again, we're doubling the 5 gigahertz performance on this, and we're also including a 2.5 gig uplink to be able to support those higher speeds. And then we have our 620D, which is going to be sort of our mid-tier 6E access point here for us. So very similar to the 610, just with 6 gigahertz support. And then if we want to jump up here to our smart antennas, we've got 3 models here that have smart antenna technology. Our WAX630S is our entry-level AP and our best-selling smart antenna access point. It can provide AX3000 speeds with smart antenna, 2.5 gig uplink port on it. Step up from there is our WAX640S. So this is a tri-radio access point. It operates in 6 gigahertz, 5 gigahertz, and 2.4 simultaneously for a combined wireless data rate of around 7.8 gigabits per second. And then we have what's traditionally been our flagship AP, the WAX650S. So this one is our fastest AP as far as Wi-Fi 6 goes without jumping up to 6E. It provides 4 spatial stream wireless performance on both the 2.4 and the 5 gigahertz radios. It provides a dedicated third radio just for monitoring DFS channels. So if you have to change DFS channels, there isn't the typical delay that you normally have when using DFS channels. It also has a built-in Bluetooth BLE support for those of you that want those types of advanced applications, and it has a 5 gig uplink port. So now we'll go ahead and that's it as far as the general hardware overview goes. Now we'll talk about 6E a little bit more. So 6E just indicates Wi-Fi 6 that has been expanded to also support 6 gigahertz space. So about 2 years ago, the FCC, in coordination with a number of other countries, has decided to unlock a new chunk of spectrum in the 6 gigahertz space that you can now use without needing to have a license. Historically, to operate in 6 gigahertz, you did need a license to be able to do that. And the main benefits you're going to see when it comes to 6E is you get a lot more bandwidth available. And basically there's very little that else that operates in 6 gigahertz, and 6 gigahertz does not penetrate walls very well. So you tend not to have as much interference issues, even in denser environments. So we'll start here just by talking briefly here about the extra spectrum I was talking about. So this is just showing here, the top row is 20 megahertz channels. The second row is using 40 megahertz channels. Third row is 80 megahertz channels, and then lastly 160 megahertz channels. So by increasing the amount of bandwidth we use per channel, we're essentially increasing the speed. So that's how you get a lot of the speed increases when jumping up from N to AC to Wi-Fi 6. The challenge you run into here is there's not that much spectrum available, and if you want those fast speeds, you want to use these 160 megahertz channels. Well, there's only 2 in 5 gigahertz. There's none in 2.4. And these channels overlap DFS. And if you've sat through one of my Wi-Fi 101 webinars, you know that DFS has a number of issues, particularly being that a lot of consumer Wi-Fi devices, including a lot of Apple products, don't support those DFS channels. So oftentimes for business deployments, you don't want to use DFS because you want to maximize compatibility, which means you can't use these 160 gigahertz channels. So by jumping up here to 6 gigahertz, we've now got 7 non-overlapping 160 megahertz channels. And hopefully anything that's designed to operate in 6 gigahertz is newer and then it can support these 160 megahertz channels. So you've got the ability to have 7 different APs operating, all using their own unique non-overlapping channel. You don't have to worry about those interference issues. So 6E is going to be ideal for high density deployments, whether we're talking about a high density of users or a high density of access points in an area, and also just for those needing ultra fast speeds. Now, in order to use 6 gigahertz, the client devices have to support it. So it's going to be one of those things here where we're still sort of in a chicken and egg scenario where it's easy to find access points that support 6 gigahertz. It's not necessarily easy to find client devices that do. So that's one of the challenges that we have here is we just need to wait until more devices use 6 gigahertz that are out there. Google was one of the first with the Google 6 Pro. I believe currently none of the iPhones currently support 6 gigahertz. On Samsung side of things, I think you have to go up to either the Galaxy 23 or the Galaxy 24 before you get 6 gigahertz support. And then of course, smart home stuff, inexpensive tablets, a lot of those still don't support it. So for that reason, you still probably want 5 gigahertz coverage while we wait for the clients to catch up with 6 gigahertz. Now, another thing here with 6 gigahertz briefly to talk about here is essentially right now, 6 gigahertz is an indoor only technology. In order to operate 6 gigahertz outdoors, you have to use a third-party channel coordination service, and none of those have yet been officially approved by the FCC. There are also some lawsuits in effect that may block outdoor deployment. So it's something to keep in mind. 6 gigahertz right now is only for indoor, not for outdoor. So now when it comes to the 6 gigahertz support, we have 3 access points that can support it. the NWA 220AX-6E, the WAX 620D-6E, and the WAX 640S-6E. Now, the key thing here to keep in mind when we're talking about these first two, the 220 and the 620, is these are dual radio access points. They have two radios, one radio that supports 2.4 and one radio that supports either 5 or 6 gigahertz usage, but not both at the same time. So these are what we call band flex. So there's two ideas behind this, other than to keep the price down, because you don't need as powerful of SoC if you're only operating two radios. And the idea behind this is you can deploy these today using 2.4 and 5 gigahertz. And once 6 gigahertz clients get caught up, then you can switch them over to 6 gigahertz operation there in the future. The other use case for these is just if you've got an existing deployment and you want to add some 6 gigahertz coverage in specific areas, these are a cheap, inexpensive way to be able to add 6 gigahertz APs in that space. Without needing to overlap your existing 5 gigahertz coverage. Now, if you do want to provide coverage on all three bands at the same time, you have to go up to our WAX 640S-6E. So that one does provide simultaneous coverage in all three bands. So that's it for 6E. We'll just do some really quick comparisons here, just showing you what's going on here. So we're comparing our WAX 510D with an Aruba AP 505 and the Ingenious models 357 or ECW 220. So you can see our access points have a better output power than our competition in this space. Our access point here provides free cloud coverage as well as local controller support or standalone modes, something that's missing on these other two. And ours offers dual optimized antennas where theirs don't. Another key takeaway here is the Ingenious models here are not true Wi-Fi 6. So Wi-Fi 6, and I sort of talked about this briefly earlier, Wi-Fi 6 has a number of different features that are available in it. And a lot of the access points out there either using at the lower price points or that are older are using chipsets that don't support all of the features of Wi-Fi 6. So our product does, where the Ingenious models in this comparison do not. We'll jump up here to our WAC 650S. So sort of like our flagship AP. So this competes with like the Cisco Meraki MR45, the HP Aruba 535, the Ruckus R650. All of these are 4x4 Wi-Fi 6 access points. You can see here we have better output power than most of our competition again, regardless of who we're looking at here. We have smart antenna, so only us and Ruckus offer that smart antenna technology. We have a 5 gig uplink port to make sure that you can take full advantage of full speed on both radios. So that's something that's missing here from the Cisco and the Ruckus products. We have a pass-through LAN port, which is something missing from the Cisco products there. And then again, we've got that tri-mode operation. And that, guys, that completes today's webinar. There are no questions. So if you have some questions, please go ahead and send them in now. And just while we wait to see if any questions come in, most of our webinars are recorded. And then usually within 1 or 2 days, they will be uploaded to our YouTube channel. So the North American YouTube channel is called Zyxel America channel. So you'll find those webinars archived there. You'll also find video case studies, best practice videos, new product introductions, things like that there. And then if you're on LinkedIn and want to connect to us, we are Zyxel US channel. Okay, I'm not seeing any questions coming in, so I am going to go ahead and end today's webinar. If you do have something, you can always email me directly. My email is up there on the screen, seanr@zyxel.com. You can always also just send it to your sales guy who you normally talk with, and they can get you the answer or forward it to me as needed. We do webinars every Tuesday and Thursdays. Tuesdays are normally more technical focused, going into configurations, things like that, where our Thursday webinars are generally more of like today, sort of a high level overview on stuff. So that's something to keep in mind. And of course, we're always open to suggestions for webinars and topics you'd like to see us talk about in the future. I'm going to go ahead and end today's webinar. Thank you for joining us. Hope to see you at one of our future webinars.